All right, so good afternoon, students, and welcome to this weekend's lecture, which is our lecture number 2 for the semester. Last week, we tried establishing our roadmap for the semester, and I do recollect that I showed you this illustration here that our main objective this semester is to be able to transform data and make it information. Then once we get the information, we don't stay there. Then we also transform information and make it a decision. Anytime you hear people use this phrase or word that I need to take informed decision, then means that data has been converted. You can only take informed decision when data has been processed into information and the information is informing your final decision. So I said the first day that your program, information technology, means that we need to find a way to transform data into its proper use. And so I'll still repeat, data are raw facts, but thankfully within the raw facts, information is hiding in the raw facts. And once we use our transformation processes to get the information out of the raw facts, then it becomes a processed data. Then with the processed data, we can make meaningful decisions out of the processed data. And so with all the explanations I gave last week concerning this roadmap, one word that I can use is that we want to study techniques or approaches that can be used to do this transformation. And there are several techniques, there are several approaches that can be used to transform data into information. And then information can also be processed into a useful decision. And my objective this afternoon till we close is to guide you through as to how to use one of the techniques in transforming data into information. And I'm sure by the time we end the class, you see that technique to be a very useful technique. I will start from the foundation you know, and I'm sure from there we can take off. I'm sure at a point in your first cycle education or second cycle education, you were given some data spread like this. Anytime you scatter data in this form, we call it ungrouped frequency. So this is an ungrouped frequency coming from a data that is scattered. And when you leave it like this, it doesn't make meaning. So you were taught that when you are given an ungrouped frequency data like this, you try and then group them so you could make some sense out of the grouping. And the process of grouping such as scattered data, we use frequency analysis as a tool to group these kinds of data. when they are scattered this way. And I'm sure you remember how you were doing your class intervals. So you were also taught that to make it neater or to make the process more neater, you try and do your 3-column table where the first column was representing class intervals, CI. And then the second column was representing tally. So you tally it like the way numbers were counting in the olden days. And then you convert your tally to frequency. Then finally, the frequency becomes the information. So look at the state of these numbers now. Now they are scattered. These numbers are supposedly money on invoices. So when somebody displays monies like this for you, you have 1, 2, 3, 4, 5. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 50 invoices. First invoice, 91. Second, 78. And so on and so forth. These are 50 customer invoices for the cost of spare parts. When they are scattered like this, they don't make any sense until you group them. So when you are grouping them, the idea is that, okay, let's look at the range. How many invoices had prices between 50 to 59? You need to go tally them. So you were taught that look for all prices that are between this range, 50 to 59. So you go column by column looking for 50 to 59. I don't see any number 50 to 59 here. I don't see same here, 50 to 59. I don't see same here, 50 to 59. But I see 57 here, which qualifies to be between 50 to 59. So I pick it up. No problem about that. I come here. I don't see any number 50 to 59. I come to this column. I see 52, which is also between 50 to 59. I don't see any number in the 50s here. Same in this column, same in this column, and same in the last column. In other words, if I'm looking for invoices that has prices that are between 50 to 59, then it means I'll have to tally 2. I have to. So you were taught to tally it 1, 2, and then you change the tally to frequency 2. So if anybody sees this information, the person knows that all you are trying to depict is that out of the 50 invoices that are lying down, 2 of the invoices had total cost between 50 to 59. And so that was what you were taught. And then you were able to generate a frequency table like this from the left to the right. And then every row has its frequency. So it means that with this being 2, the tally was 2. With this being 13, you were taught that you tally 13 times. So 1, 2, 3, 4, 5, like the way counting was done in the olden days. You repeat another 5, 1, 2, 3, 4, 5, and then another 3. And that is what is converted to the 13. Same thing to the 16. You do the tallying in 5s. So you have the first 5, you have the second 5, you have the third 5, and then you have the last one, making the 16. 80 to 89, the tally was the first 5, and then you have additional 2, making it 7. Same thing applied here. The first 5, additional 2, making it 7. Then the last one you have 5. And this is what you have known all this while. This is a frequency distribution table arising from a process called frequency analysis. And we want to go a bit further with this foundation you have already. That how can we explore this frequency analysis as a technique to be able to, as it were, change any raw data we have, and then out of it, get information from the data. And then once our information is done, we don't stop there. We go ahead and then make a useful decision from the information we have acquired. Now, this very process I have reminded you of. I know that you've done it already, you have knowledge about it. But this process that we have done, it has a name. It is called univariate frequency. Univariate frequency technique in frequency analysis. The word uni means one. Uni means one. And then the variate you are seeing here, it is coming from the word variable. So univariate frequency means one variable frequency. In other words, anytime you do the kind of table I showed you, it means you are considering only one variable data and you are trying to pick information from it. We want to go beyond the uni because there are 3 forms of frequency analysis. The first one is what you know, the univariate frequency analysis. The second one we want to do today is called the bivariate frequency table or bivariate frequency table. Bi means 2. So it means that if I'm to compare it with a 1, it means this is a 2 variable frequency analysis. What we know is the 1 variable frequency analysis. So example, if you want to look at the age of students, age is only 1 variable. So you can use the normal frequency table we have. But what if you want to look at the age and height of students at the same time, not at specific times? You want to know the 2 at the same time. What do you do? Can you use the univariate? No, it will not work. You need another technique called the bivariate. That is what works for the analysis of any data that is arising from 2 variables. In the course of your study, maybe at the master's level, you also encounter another technique called the multivariate frequency. That goes beyond the 2. For instance, when you go to the hospital and then the nurse is taking data on your age, data on your height, data on your weight. These are more than 2 variables. Age is 1 variable, your height is the second variable, your weight is the third variable. How can we analyze these 3 at the same time to get information? That cannot be possible with the first one, you know, the univariate. That cannot be possible with the second one we are about to do today, the bivariate. But you need another technique called the multivariate frequency. So we'll reserve this one for another day. But our focus today is to how to tally two sets of data coming from two variables. Once we are able to do that, we say we have applied the technique of bivariate frequency, which is giving us information about two variables such as age and height at the same time. So we can find the relationship between the two variables. So in doing that, just as I showed you the frequency table for this one, I said that this one is a 3-column table. You have the class intervals, you have the tally, you have the frequency. But the bivariate is coming with different table altogether, which looks a bit complex. For the bivariate, we are going to have about 9 different areas in the form of a table. So you have the table having partitions or divisions in this manner. So you are going to see the first area having a certain information. You see a second area having another set of information. You see a third area, same, different information. Fourth area, different information. Fifth area, different information. The sixth area, also different information. Seventh area, coming with a unique information. Area number 8, unique information. And then area number 9, another unique information. So we are going to observe 9 different areas. And to give you a schematic labeling of these 9 different areas, the area number 1 will represent the variables you are going to deal with. The variables you are going to deal with will use a symbol to represent them. So for instance, we can use X to represent age. And then probably we can use Y to represent height. So area number 1 will house the variables you will use for the tallying. And then from there, we'll label a second area called area number 2, which is also going to house the class intervals of X. Just as you have class intervals in the univariate frequency, this one also, it will house the class intervals of X. That's area number 2. And then area number 3 that you are seeing closer to the 2, we will label it as the horizontal total of the X variable. So we'll give it a name, which I will explain later. We call it horizontal total. And then we come to area number 4. Area number 4 looks like area number 2. It will be the class intervals for the second variable, which we are going to name as Y. So area number 4 will represent the class intervals for Y. Then the major activity will happen in area number 5. We call it the tally grounds. We will be doing a lot of activity within the tally grounds just to be able to put our information together there. Then that takes us to area number 6. Area number 6 will represent the frequencies of the variable Y. Then area number 7 just looks like area number 3, we will label it as the vertical total of the tally. Vertical total of the tally. Area number 8 looks like area number 6. It will be the frequency of the X variable. And then the most important area of all the areas, which is actually the output of our activity, area number 9, we'll give it a name. We'll call it the grand total. If we make any error, this is where a detection can be made. If we have made error in our activity, the grand total can expose us or validate that what we have done is correct. So in summary, the bivariate frequency analysis table is not going to look so simple like the one you know already from the univariate, whereby you have the class frequency, tally, and then the frequency. This is composed of 9 different areas with different or distinct information as they stand individually. To demonstrate this concept for you, let's pick an empirical example of a live data which had no meaning, but there was information hiding in it, and we want to bring out the information. And this is the data I want us to analyze this afternoon using the concept. Now it says the following data, which is represented in a curved bracket as X and Y, meaning 2 numbers. X has its number, Y has its number. So the representation of the data is this way, not one number like we saw in the previous example. This time you are given 2 numbers, the first number, comma, the second number. It says the following data, X, Y, indicates the ages, meaning X is representing ages. It indicates the ages and the systolic blood pressure, what we call the BP in Ghana, blood pressure, the systolic blood pressure of 40 patients. So this is a ward that has 40 patients, and then probably the ward nurse or the ward administrator has taken this data, the ages of the 40 patients and their blood pressures as well. And then the administrator or the nurse is representing the ages by X and then the blood pressures by Y. The question continues to say that the ages recorded are between 45 years and 65 years. In other words, there are some aged and youth in this ward comprising the 40. The ages spans from 45 years to 65 years, who are on admission at the cardiothoracic ward of the Kolebu Teaching Hospital. So the cardiothoracic ward is a place where people who have heart issues are attended to. And I'm sure one of the wards of the cardiothoracic unit is having 40 patients whose ages are between 45 and 65. Now, that is the recording. So if you see 45, 131, it means the 45 is representing X, which is the age, and then the 131 is representing Y, which is the blood pressure. In other words, the first patient is 45 years, and then the blood pressure that was recorded is 131. The second patient is 61 years, and then the pressure recorded is 138. The third patient is 46 years, pressure recorded 148. The fourth patient is 50 years, pressure recorded is 143. The fifth patient is 63 years, pressure recorded is 144. So it continues, the data continues in this fashion until you get to the last patient, patient number 40, whose age is 45 years and pressure 132. Now the question is, this data, what is it about? What is it speaking? Age and pressure. What can we do with that? We need information from this data. There must be an information from this data in which the doctor can use to work. So the nurse or the ward nurse is done with her job or his job. Just take the age of the patient, take their pressure, give it to the IT professional who is helping the doctor manage the consulting room, for the IT professional to make some analysis about this. Okay, remember at the cardiothoracic unit, you need a minimum of 30 minutes. You need a minimum of 30 minutes on each patient. A minimum of 30 minutes on each patient, because there are a lot of questions the doctors will ask them, find out so they can write the appropriate test or labs they can do. Now, can you imagine if the doctor is spending 30 minutes on each patient, and then the doctor has 8 hours in the ward like they do? It means effectively the doctor can only attend to 16 patients out of the 40. The ward is having 40, and he's spending a minimum of, the doctor has decided that he wants to spend a minimum of 30 minutes on each patient. So if he has 8 hours, it means he can only attend to 16. He can't attend to all these people. Now, when it happens that way, the doctor will have to take a decision as to which people is he going to pick to form the system. How can the doctor take this decision? The doctor must take what we call an informed decision, not a knee-jerk decision, an informed decision. An informed decision can only come from data. And because data is raw, like you are seeing it here, the doctor cannot take decision on this data until this data has been converted according to our roadmap into information, so that based on the information, the doctor can now take your 16 patients you can attend to. Remember, all of them need your attention. Once you have come to the ward, all of them need your attention. But it is not humanly possible to attend to all of them. So you need to pick the system. How are you going to pick the system? It must be based on informed decision. And so our objective here for this question is to see how we can turn around this data. We can turn around this data with a technique that can help us to transform this data into a useful information. Then out of the useful information, the medical doctor can make his informed decision. And that the technique is called the bivariate frequency distribution. We want to now apply the bivariate frequency distribution. And I said earlier on that the table is made up of 9 areas. So let's see how we can design that table for this question. And after that, the question is making some demands on us that we should find an information called marginal frequency of X. That's the first information. Then the second information the question is looking for is called the modal age interval. All these are going to help the doctor or the heart surgeon or cardiologist to take a decision. Then the third information the question is from us is called the marginal frequency distribution of the systolic blood pressure, Y. Then the final information we'll need from the data is called the modal systolic pressure interval. So we'll just do them one after the other. And then when our time is up, we can end and then continue the next time. So let's start the solution. I'm not too sure whether we can finish, but if I'm able to move faster, we may be able to finish. But don't worry, if we are not able to finish the solution today, we'll continue, God willing, next week. So let's go back to the question. It says you have 40 data. Let's make meaning out of it by using the bivariate frequency table, which comprises of 9 areas. So let's go and draw it. So this is how the table is going to look like. This is what I showed you. These are the blocks. So you have the first column, like I explained. Then you go this way. Then you move from the left to the right. Then you come below and do same. You move from the left to the right. Now, these are the 9 columns I mentioned. This is the first column, the variable area. So you could see I have positioned X and Y here, area number 1. Then this is what I labeled as area number 2, where I said it is the class intervals for X. So that's what you are seeing here. Then area number 3 is this side, where I said we'll label it as the horizontal total, which I will explain into detail when we get into action. Then this other side you are seeing as deep orange is area number 4, where I said it is representing the class intervals for the second variable Y. Then this whole big area is where I labeled as area number 5, which I said is called the tally ground, where the action spot is on this ground. Then here is area number 6, which I labeled as the frequencies of the Y variable. Then area number 7, I told you we'll label it as vertical total. Then area number 8 is also having the frequencies of X. Then finally, I said this is where we need validation, the grand total, all the actions from area number 1 to area number 8. The resultant effect is area number 9. So if there is an error in what we are doing, by the time we get to area number 9, we can detect it. If there is no error, and then there's proper validation also. We can be sure of whatever activity we have taken here. So let's now explain how I wrote these numbers you are seeing here. At least you understand the areas I've demarcated. As for area number one, I said you just put the X and Y variables there, showing that X is moving from left to right this way, and then Y is moving from the top to the bottom. That would be the direction. Whilst Y is moving down, X is moving from left to right. Let's go back to the question and see where these class intervals are coming from. Now, the question has been specific. It says that using class intervals of 45 to 47, 48 to 50, 3 dots means and so on, continue. It means you have been given the start. Start from 45 to 47, continue with 48 to 50, and keep going. So this is how we are going to do the class intervals for X. Then in addition to that, class intervals for Y is also starting from a different point. They say we should start the class intervals for Y from 125 to 129, and then 130 to 134. And then just like X, we should continue. Whenever you see the 3 dots, it means you are not done. Continue the class intervals. So the question is, if we start from 45 to 47, where are we going to end? Because the question says we should form the class intervals. Where are we going to end? The technique is to know where you end. You first of all write the initial ones you have been given. The initial one says that we should start from 45 to 47, and then we should continue with 48 to 50. So the first question we ask ourselves is, what is the difference now? From 45 to 48 is plus what? You see that when you do it, you see that it is plus 3 from 45 to 48. Then from 47 to 50 is the same plus 3. So it means that moving from the top to the bottom, you just keep adding 3 as you descend or you go down. But where are we going to end? It says, and so on, continue. It means we need to go look for the highest number of X. That's where we are going to stop. So quickly you scan through your data again with your eyes wide open to look for the highest number of X. So we start here. I see 45, I see 61, I see 46, I see 50. It means on this block, 63 is the highest X value I'm seeing. And then you use it to compare those on the right. So you bring the 63 here to check whether there's a number bigger than it. So I have 50, I have 55, 47, 60, 63 has repeated again at the side. So it means that 63 is still the highest. You keep going with that. Then again, you come to the next block. 57, 65. I see 63 here again. And then immediately I see 64. So 64 is the highest now, which has overtaken 63 because 64 is bigger than 63. So we take 64 to the next block. I see 61, 61, 63, 64 is repeated here again. And then the next one, 65 has taken over as the big X now. So now we are working with 65 as our big number for the X. We take it to the next block. Yes. Ajete, unmute yourself and ask your question. Yes, if you can hear me, Ajete, unmute yourself.
Okay, yes, thank you very much. Sorry to interrupt. I want to say that the question states the ages from 45 to 65. So from the question, can we say that the highest is 65 without going through this?
Exactly. But what about the pressure? Are you with me? Oh, I think you have gone. Now, I was saying that the ages have been stated, but what about the pressure? The pressure was not stated. So you need to confirm the 65 you are seeing. That's why we are doing the confirmation, and we use the same process for the Y. So we keep going 64, 59, 60, 46, 69, 65 is still the biggest. 62, 50, 53, 46, 57, 65 is still the biggest. 59, 46, 63, 50, 52, 60, and then finally 53, 52, 54, 62, 45. So it means that 65 is the highest data for X as it has been stated in the question when he was drawing our attention to it. But I was asking him that it was done for only the ages, it wasn't done for Y. So we needed to go through this process and then we do same for Y. So with that understanding, it means that this is how your class intervals is going to be for X. You add 3 to 48, and then that gives you 51. You add 3 to 50, you have 53. You keep going. We want 65 now. You add 3 to 51, you have 54. You add 3 to 53, you have 56. You add 3 to 54, you have 57. You add 3 to 56, you have 59. You add 3 to 57, you have 60. You add 3 to 59, you have 62. And then finally, you add 3 to 60, you have 63. You add 3 to 62, you have 65. And because 65 is the highest, we end. We don't proceed again. And that is what you are seeing here in the table. That is why we ended at 63 to 65 after starting from 45 to 47. We end at 63 to 65. Immediately you end, you draw your line, and then you record the next column as your horizontal total column. That's the last column after your last class interval for X. So we do same to Y. I was telling Ajete that they haven't stated the highest value of Y here, like the way they did for X. So painstakingly, you have to go through like we were doing, looking for the highest value for Y. So we use the same method by checking the Y. So first block, I see 131, 138, 148, 143, 144. So it means that in this block, we are being told that 148 is the highest number for Y. We take it to the next block. 128, 135, 138, 146, 144. None of them can overtake 148. So we move to the next block, 135, 140, 148 has been repeated, 132. Then I see 150. So 150 has taken over as the biggest number for Y. You take it to the next block, 142, 144, 138, 146. I see 152. So 152 takes over as the highest number. Then we take it to the next block, 138, 150, 144, 150, 144. None of them is bigger than 152. So we still keep 152 as our biggest number. Then 144 I see 152 repeated again here like this. Then 135, 144, 150. Next block, 154. So 154 takes over now as the biggest number for Y. Then we take it down into the other side, 135, 146, 148, 135. Then the last block, 125, 146, 144, 145, 132, meaning that 154 is the highest data for Y. And that is going to inform our class intervals. So this is our class interval is going to be like just as we did for the X, the Y will look like this. So we were told to start from 125 to 129, and then 130 to 134, and then it stopped. So we need to look at the difference. From 125 to 130, it means as you move down, you add positive 5 on the left. What about the right? 129 to 134 is the same 5. It means as you move down, you add 5 until you get to the last number we are looking for, 154, and then you stop. So we keep going. 130 plus 5, 135. 134 plus 5, 139. 135 plus 5, 140. 139 plus 5, 144. 140 plus 5, 145. 144 plus 5, 149. 145 plus 5, 150. And then 149 plus 5, 154. The moment we get to 154, we stop because that's the highest, 154. And that reflects in our table. So you see that in our table, when we started from 125, the moment we got to 154, you stop. And then you draw your line from the left to the right to go and meet the first one you have drawn already. Then you label this side as the vertical total. The first one, we labeled it as horizontal total. So this one will be vertical total. And then now you have where the horizontal and the vertical are meeting. That is where we are calling the grand total. This is where the vertical total and the horizontal total are meeting to form the grand total. I saw some hands up. Yes, Solomon, unmute yourself and ask your question. Yes, Solomon. Okay, so I think, Solomon, we have lost you because of connectivity. You can try and write your question down. When there's another opportunity, then you can ask. So you can unmute yourself and then ask your question again. Okay, so let's continue. Now, having done the table or the area for this, we are now ready to tally these numbers. We are going to tally X and Y at the same time. And so watch me as I do it. It's going to take the form of like the way you were taught how to plot a graph. Some time ago, you were taught that to plot a graph, you need to get your X axis and then your Y axis. So for instance, when you are asked to plot the point 2, 4, it means the first one is representing X, and then the second one is representing Y, meaning go to the X axis, go and mark your 2. So you mark it like this. So this is your 2, and then the Y is 4. So you go mark your 4 on the Y. And so when you are plotting this coordinate points, all you do is where 2 and 4 will meet. That is where you are plotting. So you put your point there and then you circle it as
Sir,
your point.
sir, good afternoon.
Yes, go ahead.
Sir, this is Solomon. Yeah, I see clearly that you were using 3 intervals for the X and 5 intervals for the Y. I don't understand, sir.
Yes, so stay on. Have you seen this one? 45 to 47, 48 to 50. Have you seen it?
Yes, please.
Okay. So that was what I arranged here. 45 to 47, 48 to 50. And then I was asking from 45 to 48, it is plus what?
Plus
Okay.
3.
Very
Plus
good.
three.
Plus
Very
3.
good. Plus 3. So 47 to 52 is also plus 3. So it is telling us that as you are going down, keep adding plus 3 till you get to the last number, 65. That was why we were adding plus 3 for the X. Then we came to the Y. The Y, we were asked to start from 125 to 129 and then follow it up with 130 to 134. And I also arrange it like this: 125 to 129, 130 to 134. Then we went through the table and we saw that 154 was the highest. So it means that we need to keep coming down till we get to 154. How are we coming down? It means we need to look at the difference between the first two we have been given. From 125 to 130, it is plus 5. From 129 to 134 also, it is plus 5. It means that as you are going down, keep adding 5 till you get to the last number. This is the reason why we were using plus 3 on the X and then plus 5 on the Y.
Okay, thank you. Well understood, sir.
Very good. So with that information, we now have to go and tally the numbers. And I was using this illustration for you that when you are asked to plot a point 2, 4, you look for X, you look for Y, where they meet, you plot. So what we are going to do is that on the table, our X is moving from left to right. Our Y is also moving from the top to the bottom. So we are going to see where they will meet. Where they will meet, instead of us putting a point or a dot like this, we are going to use the tally stroke like we were taught. So we are going to stroke it this way. Okay, we just slant it, we stroke. Any point we see, we stroke. Anywhere we have to do, we stroke. When our strokes becomes more than 4 and it's going to 5, we don't go this way, but we cross like we were taught some time ago to get it. So let's learn how to do the tallying of this on our dashboard. So this is the dashboard we have now, which we are going to work it. All the data that you saw, I have written them here so that when I'm plotting, you can look at it and we all refer to it. That is why I wrote them side by side so you can follow. So let's start the tallying in a way that probably we can all follow what is happening. So I'll start with the first one. The first one, we are supposed to tally X 45, Y 131. How do we do it? We look for X, we look for Y, where they will meet, then we tally. So X 45 is in this range. Y 131, we have to look at it from the side. So whilst 45 is coming down like this, from the top to the bottom, 131 will also be coming from this block, from this side, like you are seeing me do. So this is 131. So they have met. 131 is coming from the side, 45 is coming from the top. The box in which they meet, or the cell in which they meet, like you are seeing, the cell in which they meet, that is where you tally. So this becomes our first tally. We call this one 1. This is our first tally. This is how you stroke it. So this is 1, the first tally. Okay. So we are going to do that for all the cells you are seeing from left to right. This is 125 to 129 cell. This is 134 to 130. This is the third one, 135 to 139. Making sure the lines are creating the boundaries for us. 140 to 144, 145 to 149, and then 150 to 154. So in the same manner, 45 to 47, we move this way. 45 to 50, we move same way. 51 to 53, we just want to make sure that all the cells are standing out. There is no intersection. 57 to 59, 60 to 62, and then 63 to 65. So we've done the first one. Yes, Solomon, go ahead.
Sir,
Yes.
the Y value was 131, but we ended at 129. I think that's I don't know.
Watch. Are you seeing the line?
Yes, sir.
So we are not at 129. We are here. We are between 130 to 134.
Okay.
That is why I've drawn the markings again. So you can see it clearly.
Okay.
Are you okay with that?
Yes, sir, please. Thank you.
Okay, very good. So let's continue. So we are done with the first one. Let's do the second one. 61 against 138. So we go look for 61 in the X. So the 61 is in this range. And like I do, it will keep coming down, waiting to meet 138 at the side. So you have the 61 coming down this way, looking for the box in which it will meet the 138. And then this will be the box, because 138 is in this region. So 138 will also be coming from the side this way, and they will meet here. So this will be our first tally in this box after the previous one. So we have our first tally here. We have first tally here also, and that is data number 2. We have tallied it. Then we go ahead and tally data number 3, 46 against 148. So 46 is in this range. We go down looking for 148 by the side. And then fortunately we land in this box. This box is 145 to 149. So we find the 148 here, and this becomes the first tally also in this box. So that is also done. Then we move to the fourth tally, 50 against 143. So 50 will be in the second column. So 50 is here. And then we go down looking for 143 by the side. So we keep going till we get to the box where we'll have 143. And this is the box where we'll have 143. So we have our first tally also in this box as 50 and 143. And that is also done. Then we move to data number 5. Is 63 against 144. So 63 is in the last block. Then we look for 144 by descending, coming down, and then watching the side at the same time to get 144. And this is the cell or the box that we can get the 144. So this becomes our first tally in this box as well. And so this data is also done. Then we look at 50, 128. 50 is in the second column. So we look for 128 by coming down. And fortunately, it's just this box, because this box is 125 to 129. So 128 is here. And this becomes our first tally in this box as well. And this is also done. Then the next data is 55 against 135. So 55 is in the fourth column here. Then we look for 135 by coming down, and then we land at the third cell, this one. So this becomes our first data point in that cell, and that is 55, 135. That is also done. Then we move to 47 against 138. 47 is in first column. We move looking for 138, and this is 138. So this also becomes our first tally in this box. That is also done. Then we move to 60, 146. 60, 146. 60 is the last but one column. Yes, Emmanuel Tete.
Okay, sir, please, can you please revisit the point 50, 128?
Okay, 50,
50, 128.
128. Okay, so 50, 128. 50 is here. Oh, okay. All right. So that was an error. It's supposed to be, thank you. It's supposed to be here. Let me quickly clean this one with the eraser, and thank you for your vigilance. So this is
No,
not.
sir, please, you set that one
It has
to
to be up.
Oh, sorry,
what
the up one.
It should be
Yeah,
it should be in the ranges between 125 and 129.
All right. So I should rather clean this one, 125 to 129.
yes, please.
Yes, that
Okay,
one.
okay. Thank you. Very good. And I'm happy you are following what we are doing. So when there's an error, you can detect it. That's good. And so we can continue now. The error has been corrected. It means that this will still have to be there. And this is also still there. So let me check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I see a hand up. Is this? Yes, Zed.
Please, the 128 is supposed to be in the second, the second,
Oh, okay. So it's supposed to be
second
here.
column. Yes.
Here.
Yes.
Okay. All right.
So you clean the one below it.
Yes. Thank you very much. I'm doing that. So this is not
Thank you,
supposed
sir.
to be. Yeah. Thank you. It would have affected our results. So it's good you have detected it on time. So we can continue now that we've corrected all the errors. Let's move on to the next data. The next data is 60, 146. So we come, 60 is in this column. We look for 146 and then we land here. So it means that this will be our first tally in this box. So I can see you have understanding now. I'll move a bit faster. This is done. We move to 63, 144. 63 is in this column. So you come down, look for 144. It means we are landing here. 63, 144. This becomes the second tally in this box. So that is also done. Then 57 against 135. 57 is in this block. Then we look for 135. We land here. So fortunately, we land here as the first in this box. That is also done. Then we move to 45 against 140. This is 45. So we look for 140 and then we also land here for the first time. So this is the tally mark. That is also done. We move to 63, 148. 63 is here. We move down looking for 148 and then we land in this cell. So this will be our first tally in this box. Then we have 45. Then we have 45, 140. So 45, 140, we come down and this becomes our second tally in this box. Let's continue with the rest of the numbers because I wanted you to follow. That was why I wrote them side by side so that we all follow. So there are some at the top there. Let's go pick them and then continue with what we are doing now. So at the top here, we have 64 and 150. So 64 is in this column. We look for 150 by coming down and then we land in this cell as our first tally in that cell. So this is also done. Then we have 61, 142. 61 is in this column. We come down to look for 142 and then we land in this cell for the first time. This is also done. Then 61, 144. 61 is in this block. We look for 144 by coming down. And then we have a second tally in this box. This is also done. Then we have 63, 138. So 63 is here. We come down looking for 138. And then we land in this box for the first time as our first tally. This is also done. Then we have 64, 146. So 64 is in this range. We come down and look for 146. And then we land here. We have a second tally in this box. This is done. We continue with our data. 65, 152. 65 is in this column. So we look for 152 by descending down. We land in this cell for the second time as our second tally in this box. This is done. 64, against 138. 64 is in this block. Yes, Alfred.
Hello, sir.
Yes, Alfred.
Please, 61, 144. I don't know if you can go back again. 61, 144.
I should check the 6144.
Yes, please. 61, 144.
61. Okay, so 61 is here.
Mm-hmm.
Then 144 is here. Have you seen it? This 144.
Wow.
This 144. So that's where we have landed. You see, every area is having two cells. Have you seen it?
Yes, please.
Yes, every area has two cells. So I'm shading in the orange, because I'm going to write something in the white ones very soon for you. That is why I'm shading in the orange areas. So the 61, 144, the 61. Yes.
Sir, please.
That cell was supposed to be three. It's supposed to have
Sir, please.
two.
Won't it be the 61, 144? Won't it be the column of 63, 144? The column
61.
of 60.
No. 61 is between 60 and 62, or
Yes. And then the
so
144.
then the 144 is
Yeah.
coming from here. It's coming from here.
Okay.
So that's how they met. Are you getting it?
Yes.
So I'm saying that every column has two cells. So see, 125, 129, 12, 130 to 134, 12. I'm saying I intentionally did that because the white lines, okay, so probably I understand you. It's because I put this one in the white line. That is why you are getting confused. It's supposed to be in the orange line. So let me put it there and clean this one here so that you don't get confused with what we are doing. Okay, so I've done that. So see the first line. There's no mark. There's no mark in the white line. See the second one. There is no mark in the white line. The third one, there is no mark in the white line. The fourth one, no mark in the white line. Fifth one, no mark. And then sixth one, no mark. I'll write some things there for you later. And you understand why I left those places like that. So yes, Christian.
So for clearer understanding, the white lines are no different from the orange lines.
They are not different from the orange lines. You can use any of them.
Okay. See.
So if you decide to use the white lines, use the white lines throughout. If you decide to use the orange lines, use the orange lines throughout.
Okay, sir.
That's the explanation I was giving him. So that is good. If you don't understand something, please feel free and ask. Don't let us pass and go. If you don't ask questions and you are watching the video, you will still not understand what you are not understanding now. So we need to clear our minds. When people ask questions, let's be patient with them. It's because they want to clear their mind on something. Yes, Nathaniel.
No, sir.
Yes,
Hello,
go
sir.
ahead. Yes, Nat, go ahead. I can hear you.
Good evening, sir, once again. Sir, so I'm asking, so in practical exams, are we going to make this plenty table? Because normally you said the columns are 9, but now the pink is different and the white down to is different. Is it not making the columns more than 9, please?
No, in exams, don't do 2 columns, do 1 column. I'm teaching you, and I'm going to write some things I want you to understand. That is why I have made my lines 2 in each of the columns. But the schematic column I taught you, they were areas. I said areas. I said you have 9 areas, not 9 columns. I said 9 areas. So
Okay.
you can have plenty columns within the area number 5. That was why I labeled it as the point of action, the activity grounds. That is where most of the things. But what I said is area. Area number 1 is what you are seeing. X and Y are in area number 1. The class intervals for X are in area number 2. The horizontal total I wrote here is in area number 3. The class intervals you are seeing here, that is area number 4. Below the class intervals, the vertical total you are seeing here is area number 7. After the area number 5, the action grounds, see, there's a column here. This is area number 6. And then look at this down here. We haven't come here. It is aligning with the vertical total. Later we'll do something here. That is area number 8. And then the grand total is area number 9. So as for the columns, plenty columns you are talking about, it will depend on the range of values they will give you. Assuming they told us that the age is starting from 45, like Ajete was drawing my attention to 100. It means we couldn't have ended at 65. We'll keep going till we get to 100. And once we keep going, it means that we'll create more columns from left to right. So as for the columns, it will depend on the question and the range they will give you. But the initial explanation I was giving you was that you are going to have 9 different areas, not 9 different columns, 9 different areas. All right, good. So we continue with our next data, which is, let me zoom a bit closer for you. That is also too much. So I think this is a bit better. Our next data is 64, 138. 64 is in this range. So we look for 138 and then we land in this cell. So this is our second in this cell. This is also done, 64, 138. 59, 150. 59 is in this column. So we keep going down looking for 150 and then we land in this cell. So this becomes our first tally in this cell. That is also done. Then we come to 60, 144. 60, 144. So 60 is here. We come down and look for 144 and then we land here. So it means this is going to be our third tally in this box. 60, 144. This is also done. Then we look at 46, 150. 46 is in the first column. We go down looking for 150. Then we land here. This is the 150. So that is also done. The next is 49 against 44. 49 is in the second column. So we go look for 144 from the side and we land in this column. And this becomes our second tally in the column. So this is also done, 49, 144. The next is 62, 144. So this is the 62 column. We go down looking for 144 and then we land here. So we have a fourth tally. A fourth tally in the cell. Yes, Kumi?
Hello. Good evening.
Yes.
So please, the numbers in the row section, you said that the area is 4. Is it all the time the area is going to be 4? Or if the numbers in the column section changes, the area is also going to change?
The area will not change. The area will always be 9. So let me repeat. See area number 1. Area number 1 is where we have X and Y. That's what I've circled. This area number 1. Good. Okay. Area number 2 is where we have these class intervals from 45 to 63. So all this stretch is forming area number 2. Are you with
Okay.
me? Then
Yes,
area
please.
number 3. I'm saying area number 3 is starting. Immediately you end area number 2, then area number 3 will show up. That is what we call
Okay.
the horizontal total. So you see that
Oh,
1, 2, 3 is still there. Then area
yeah.
number 4 is the class intervals you are seeing here. So all this is forming area number 4.
Okay. So, say, please, does it mean that we don't have to draw any scale? Because starting from
No.
125.
No, don't draw any scale. Use a free hand. You can even use a free hand to draw. You don't need a scale. We are not plotting. No. We are
Okay.
just
So
marking.
it doesn't have any formula, because I've seen that from 129 we are skipping from four each. We keep on skipping 4 interval.
No, you mean here?
Yes, please.
No, yeah, that is what the question said. Look at the question. The question said for the Y, see, it said we should start from 125 to
Okay.
129.
Then I didn't see the question.
Then we should follow it up. So it was the question that made us know that then from 125, if the next number is 130, it means it is plus 5.
Okay.
Then 129 to going to 134 to means plus 5.
All right.
Are
Understood.
you getting
Thank
it?
you very much.
And the
Yes.
table 2 says that our highest Y is 154. So we should go out till we get to 154 and then we stop.
Okay.
And so the
Thank you very much.
movement is the plus 5. Yeah, was the plus 5 you are seeing. So it's coming from the question.
All right.
Good. So
Thank you.
any interval the question will give you, that is what you follow. You don't use your own interval. Just always the question will give you the interval you should follow or use.
Okay.
Right.
Okay.
Right.
Thank
So
you,
let's
sir.
continue. Good. So now we are at 62 144. 62 144. So 62, I think I did that. That's what landed us here as the fourth one. So this is done. Then 50 152. So 50 is here. We go down looking for 152 and then we land in this box. So that's the first tally in that box. This is also done. Then we move to 53 135. So 53 is here. We look for 135 and then we land in this box. And this is the first tally also in this box. So this is also done. 46 144. 46 is in between 45 and 40. So we are in this column. So we go look for 144 by going down and we land in this cell and this becomes the third tally in this cell. This is also done. Then we have 57 150. So 57 is in this column. We move down looking for 150 and then we land here. So we have the second tally for this cell. This is also done. Let's take the last set of data. The data is 40. We have done almost 30 something. Let's look at the last set. 59 against 154. 59 is in this column. We move down looking for 154 and we land in this cell. So this becomes the third tally in this cell. So this is done. This is done. Let's move to the next one. 46 135. 46 is here. We go down looking for 135 and we land here. And this becomes the second tally in this box. This is also done. Then we have 63, 146. 63 is here. You go down looking for 146. You land in this box as the third tally in that box. So 63, 146 is done. Then we have 52, 148. 52 is here. You go down looking for 148, and then we land in this cell for the first time. So this is the first tally in this cell. This is also done. Next is 60, 135. This is the 60 column. 135 means we come down and we land in this cell, and this becomes the second tally in the cell or box. So 60, 135 is also done. Let's look at the last five. 53 against 125. So 53 is in this column. Then 125 is in the first row as well. So 53, 125 means this is the first time we are landing here. This is also done. 52, 146. 52 is here. So we move down looking for 146, and then we land in this cell. So this is also done. 54, 144. So 54 is here. We go down looking for 144, and then we land in this cell for the first time. So this is our 144. This is also done. Last two, 62, 145. 62 is in this column. So we go down looking for 145, and then we land in this cell for the second time. This is done. And then the last but not the least, 45 against 132. So 45 is here. We come down. This is 132. So this becomes the second tally in this block, and this is done. So ladies and gentlemen, this is the first action in this cell that you are supposed to do. Let's proceed to do the second action. If you remember, at the lower levels, anytime you are doing your 3-column table, I did mention of when we started, when you have your class intervals, and then let's say you have 20 to 25, and then 26 to 31, and you have your tally here, and you have your frequency here. If your tally here was 1, 2, 3, and your tally here was 1, 2, 3, 4, 5, it is the tallies you change into frequency. So from here, you record 3 as your frequency because of the tally you had. And then same thing for this, you record 5 here because of the tally you had. In other words, it is the tallies that are converted into the frequencies. And so we are going to use the same principle for what we have done. We are going to convert all these tallies you are seeing here into frequencies. And this is how we do it. And that was the reason why I left some one line below. So when we come to this side, we are working block by block. Now here I have 2. We counted 2. So it means that we record a frequency of 2 here, and then you put a circle around it, just indicating that in this cell, we counted 2. You do the same thing for the second one. Here too, we counted 2. So you record your 2 in the white cell. So that is also 2. Then the third one, we counted 3. You write your 3 and then you circle it. The next one, we counted 1. You write your 1 and then you circle it. The last one also, we counted 1. You write your 1 and then you circle it. Then you move to the next column. Same procedure. We counted 1. You write your 1. You circle it. We counted 2 here. You write your 2. You circle it. We counted 1 here. You write your 1. You circle it. You move to the third column. Same thing. We counted 1 here. You write. We counted 1 here. You write. We counted 2 here. You write it. And then we move to the next column. Here also we counted 1. Here we counted 1. Next column we counted 1 here. Here we counted 3. The last but one column we counted 2 here. We counted 4 here. We counted 2 here. And then the last column, we counted 2 here. We counted 2 here. We did 3 here. And then we ended with 2 here. So that is the next level of activity you do. After getting the tally strokes, you change the tally strokes into frequencies. So we are still working at the area number 5 called the tally grounds. We are now going to add the numbers in a vertical way and then in a horizontal way. When you add the frequencies in a vertical way, we say you are doing vertical total. And then after that, we'll add the numbers in a horizontal way. When you do that, we say you are doing a horizontal total. At the end of the day, if we are moving from the top to the bottom and from the left to the right, the answer we get here, the answer we get at the grand total will prove to us whether we have made a mistake or not. That is where the validation takes place. So let's quickly do those additions. We are now moving from the top to the bottom, vertical. So let's add 2 plus 2 plus 3 plus 1 plus 1. When you put all together, you will record 9. So the total here, from the top to the bottom, you have 9. Then the second column, 1 plus 2 plus 1, you record 4. Third column, 1 plus 1 plus 2, same thing, you record 4. Fourth column, 1 plus 1, you record 2. Fifth column, 1 plus 3, it means we have 4. The next column, 2 plus 4 is 6. 6 plus 2 is 8. We record 8. And then 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 3 is also 9. Now, if we add these numbers from left to right, and we don't get 40, because the question said that the patients are 40. If we add those numbers and then we don't get 40, it means we have made an error somewhere. And so if it is a program we are writing, the program will not run because the validation has not gone through. So that is the reality check here. If we add and we don't get a 40, there's an error. So let's check. 9 plus 4 is 13. 13 plus 4 is 17. 17 plus 2 is 19. 19 plus 4 is 23.
23.
23 plus 8 is 31. 31 plus 9 is 40. So it means that we have been validated as right. All the activities we were doing here, we have counted them and arranged them very well. So we are having 40. But that is not all. It means that when we are also coming from the top and then adding the numbers we'll get here, if we still don't get 40, it means we've still made an error, because the numbers we get here also must give us a grand total of 40. So now let's do the horizontal additions. Now we have 1 plus 1 moving from left to right. So this will record 2 for us here. Then this second line is only 2. So the total is 2 as well. Then we move again from left to right. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 2, 7. 7 plus 2, 9. So we record. Then 3 plus 2, 5. 5 plus 1, 6. 6 plus 4, 10. 10 plus 2, we have 12. Then we have 1 plus 2, 3. 3 plus 2, 5. 5 plus 3, 8. Then finally we have 1 plus 1, 2. 2 plus 3, 5. 5 plus 2, 7. Let's check the addition now. 2 plus 2 is 4. 4 plus 9 is 13. 13 plus 12 is 25. 25 plus 8 is 33. 33 plus 7 is 40. It means this side too has tallied. So it means that our horizontal total is also correct. So at the end of the day, you have a table like this displaying the numbers here and the grand total like we have here. We have the numbers here, and this is the information that is coming out from the data that we are going to use to advise the doctor next week. Next week, God willing, we are now going to look at the information we have and then how we are going to change the information into a decision. What you are seeing here is like an exercise book. Every exercise book has margins. So for instance, if you look at the book you have been writing in, or probably you have one in front of you, this is what you see in the book. This is the actual space of the book. Then you see if it's a blue line they have used to draw your lines, you see the first blue line like this, and then a big space at the top. And then when you get to the down to, there is a last blue line also that is also leaving another big space below. Then from there, if you look at side and side of your book, you see a red line moving from the top to the bottom. And then you see another red line at the edge also going this way. Now, your exercise book is an example of the space we have used, where you have area number 1, area number 2, area number 3, area number 4, area number 5, area number 6, area number 7, area number 8, area number 9. What information can we get from these areas? That is the next question we'll answer next week. The information is called the marginal frequency. Marginal frequency. Marginal is coming from the word margin. And so in your exercise book or notebook, you have 2 sets of margin. You have 2 sets of margin. If you have one in front of you, you can check. You will see that the first set is the red line. So you have an area like this, the red line to the left, and then you have the red line to the right, like this. So red line here, red line here. We call them margins. Okay. Apart from that, the blue lines as well that you have, you see that the first blue line you have, and then the last blue line that you have, the space between the first blue line and the top of your exercise book is bigger than the small lines you are seeing here. In the same way, the last blue line to the end of your exercise book, to the space you are seeing is also bigger than the small lines you are seeing. Now, this is what we are going to do next week. Next week, just like your exercise book, we are going to pick the vertical margins like this. Okay, the vertical margins are where I've shaded red. We are going to combine them. We are going to combine the vertical margin on the left to the right. We are going to combine them in the form of a table. When we combine them, we'll call it marginal frequency table. It is going to give us a specific information from the data. To give us a specific information from the data. Then we'll not end there. After that, just like I did for the blue line at the top, we are going to pick the first blue line in the top, which looks horizontal like this, and then match it with the last blue line that also connects to the down like this, and then we'll connect the two this way. We'll connect the two, and when we connect the two, it's going to give us another marginal frequency where we'll have specific information the doctor can use to take a decision. And then out of the two, we will know the most occurring age in the ward, the people who are within a certain age bracket, who form the highest number of patients. And then we will also look at those who have a certain blood pressure in a certain range. Then out of the 4 information, the modal age, the systolic pressure, the marginal frequencies, we are going to conclude to guide the doctor as to what he should do, so that when the doctor comes and he picks his first 16 by saying that I will attend to this patient, I will attend to this patient, I will attend to this patient. When the doctor starts picking his 16 patients, we can have a reason. We must get a reason. And then the reason must be fair. The reason must be a fair reason. It shouldn't be a biased reason, like whom you know or who knows you. or probably you know the doctor or you know the nurse, the doctor will have to operate with a fair reason. And before the doctor can operate with a fair reason, we as IT professionals are supposed to give him information from the data we have. And that is how we are going to conclude tomorrow. Yes, Kumi? Next week.
Hello, sir.
Yes.
Sir, please, is there going to be a situation whereby we are going to keep this data in an Excel format?
Oh, yes, of course. When you start coding, you put it in an Excel format. I'm just showing you the algorithm. All we are doing is called algorithm. We are building the program step by step. And the program is about fair selection. We want to help the doctor to do a fair selection with the program. So all we are trying to do with the plenty stuff you have seen me do today, with this table you are seeing here, all these are algorithms we are building to be able to get the program running, for the doctor. Any question? Because I'm done. Any question on what we have done today? Because our time is almost up. We can only continue this next week. Any question again, apart from what Kumi asked? All right, so I'm sure you've had enough of this today, and God willing, next week, like I said, we will continue to answer the 4 questions you are seeing here. And then that will give you a fair idea as to how to be able to build a good system that can help professionals to, you see, all we do is that we help professionals to make quality decisions. That is all. All you are doing in your study is to help professionals to make quality decisions. And like I said from the beginning, the decisions cannot be based on raw data. We have to convert the raw data into information. And this is where the IT professionals come in. This is our line. Just convert the data into information, allow the professionals to make their decisions from the information you have gathered for them. On that note, we want to end the class for today, and I'm adjourning the class until next week, 3 p.m. On that note, I wish you a good weekend.
Thank you, sir.
Wow.
one is 18. Seven, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm looking at 18. Bring up the yeah, which one? What do you like to do of using? What do you like to do on your free time? Oh.